In this exercise, we're told to calculate the probability between two numbers, O and 0, for the normal O1, and that would be the area in color yellow, which is the area beneath the density function between 0 and 2. To do so, we would have to calculate or look up for the probability on the right of 0, which would be 0.50, as it's the value which leaves 50% of probability on its right. And then we should subtract the probability on the right of 2, as the tables are providing us the probabilities on the right of positive numbers. Doing so in the tables, we would look up for the 2 and the 0. 0.0228 would be the probability on the right of 2, and that's the result of subtracting that probability. In this exercise, we are being told to calculate the probability between minus 1.96 and 0.98 in the tables of the normal one. That would be the area beneath the density function between a positive number and a negative number, in color yellow in the graph. To do so, we would need to write those numbers on the left of 0 and on the left of 0.98, and to do so we would need to calculate the probabilities on the right of the positive number and on the left of the negative number. But as the tables provide us the probabilities on the right of positive numbers, that would be the same as calculating the probability on the right of 1.96. If we write that, and being 1 the whole probability beneath the whole density function, this would be the way of expressing what we need to calculate. That would be 1 minus the probability on the right of 1.96 minus the probability of z being higher than 0.98. As these are probabilities on the right of positive numbers, we just have to look up for these probabilities on the tables of the normal, looking for the intersection of these percentiles. That would be 0.025 minus 0.1635, and that equals to 0.8115. Now in this exercise, we are being asked to calculate the probability between two symmetric numbers, positive and negative. That's a probability between minus 0.48 and 0.48. That would be the area in yellow in the graph. To do so, we need to write the two numbers we are being asked, the two percentiles. Those would be those in the chart. And we have the probabilities on the right of positive numbers. So the probability on the right of 0.48 would be the one in white. We should go to the tables of the normal, and then we should find this number linking rows and columns. So by difference of the whole probability, which would be 1, we can subtract twice the probability on the right of 0.48. That would be 1 minus 2 times the probability, which is, as we have found on the tables, 0.3156, and that number would be 0.3688. In this exercise, we're being told to calculate the probability for a random variable which is distributed as a normal 10 with a standard deviation 3, the probability between 7 and 13. To calculate this, first of all, we need to standardize this random variable, and to do so, we need to subtract the mean, which would be 10 in this case, and to divide over the standard deviation, in this case 3. We have to standardize the whole all the values, So 7 minus 3 minus 10 over 3, z would be the normal 1, and 13 minus 10 over 3. Those would be the numbers we have over there. And when we have these standardized values, minus 1 and 1, we can go to the tables of the normal, and then we can calculate the probability. To do so, we can, as they are symmetric numbers, we can calculate the probability on the right of 1, and as we are looking for the probability between minus 1 and 1, that would be 1 minus the probability on the right of 1. And that's the result of this exercise.
I don't know where I'm going, but I sure know where I've been. Hanging on the promises of the songs of yesterday. Well,